Next, we invite not only the robotics field, but next Yohei Oseki, Professor Yohei Oseki is not the major is robotics. So I'm very happy to hear your talk. So please start, Professor Oseki.
All right, can you hear me?
Yes.
Okay, good. Let me share my screen though. Okay. All right. Okay, so first of all, thank you very much for inviting me as a panelist in this great roundtable, Shimura-san. As Shimura-san introduced me, I'm not a robotics person, but I'm a mainly cognitive scientist, mainly language domain. But I've been using computational models and actually human behavior and also neuroscience experiments to evaluate those computational models which perform language processing to reverse engineer human language processing. Okay, so that's the title. Okay. All right, so as you know, the language is one of the main important higher order cognitive functions of human. And I think that's why I'm invited here. Okay, so this is a list of 3 items which Shimura-san asked us to mention in our introduction. So I'm gonna just go through those 3 topics here. Okay, so first of all, I'm gonna introduce myself just a little bit. Okay, so I'm Yohei Oseki, assistant professor at the University of Tokyo, and also a visiting scientist at the RIKEN Advanced Intelligence Project, AIP. And I'm a cognitive scientist by training, but I've been, as I said, combining computational cognitive theories of language and cognitive neuroscience and natural language processing, NLP techniques to get more human-like language processing models. And this is I just recently moved to the University of Tokyo in this April, and I recently launched my lab called Language Computational Cognitive Science Laboratory. Sorry, this is Japanese lab website, but this is still under construction. So this is my group. I direct this laboratory now for human language processing, and also its comparison with machine language processing. All right, okay, so I'm gonna situate the language within this broader context first, and then I'm gonna talk about some specific experiments which we've conducted recently, and then I'm gonna talk about some future direction for situating language within the broader context of cognitive robotics. Right, so within the bigger language community, especially natural language processing, there are 2 lines of research. Okay, and the first thing is scientific study of language, of course, right, where people have been conducting some behavior or maybe neuroscience experiments to uncover human language processing and human language learning. Mainly by using symbolic systems, by using some production rules to generate some latent structures, to generate some language strings, okay, by assuming some linguistic knowledge is endowed genetically, like a program, genetically, without any learning taking place. Okay. And another line of research is, of course, engineering study of language, which is, of course, called natural language processing, NLP, or computational linguistics, which implements computational models which perform some tasks which involve some language processing, things like machine translation or automatic speech recognition. Right? And they are try to model those maybe independently of scientific study of language. They're trying to model some language processing and maybe language learning based on some kind of a big data called corpus. And current NLP research is dominated by deep learning techniques, as you can imagine. And those fields are using neural net models. Without assuming any innate knowledge within the system and the model. And my research is try to combine those 2 strands of research Okay, human language processing and human language learning on one hand, and machine language processing and machine language learning or machine learning on the other. We try to compare the human language processing and the machine language processing to reverse engineer human language processing, and we try to get insights from scientific study of language into engineering study. So that's the agenda. So this is like sometimes called cognitive modeling or cognitive computational modeling of language or something like that. So here I doubled this field as a computational cognitive science of language in this case. Okay, and this is the one piece of result which we've recently done. So we compared the basic like now baseline model called LSTM and the other more recent language processing models like transformers. Maybe you heard the name like GPT or BERT or something like that. Those are state-of-the-art language modeling model. And we compared those artificial neural nets against human language processing data, especially eye tracking data in this case. And we evaluated those computational models now used in NLP. And we basically found that not so big models are more human-like in terms of human language processing. Those green models are smaller than those red models, but those green models are more human-like in terms of human language processing, if you take a look at the y-axis in this figure. And so that's kind of interesting result. So state-of-the-art language models are not necessarily human-like language processing models. And we also combined the symbolic structures into recent artificial neural network models to try to model again the human language processing data. Okay? And here, so this green one is a model with symbolic structures, and this model is outperforming other baseline LSTM models and other models, suggesting that like human language processing is using both maybe symbolic structures or latent hierarchical structures, and also artificial neural net-based inference. That's another piece of result. Okay, and for the maybe next generation of language research within maybe this cognitive robotics field. Okay, so this is famous math three levels, right? If we map out those scientific study of language and the engineering study of language into those three fields, maybe symbolic models correspond to computational theory level, and NLP maybe can be regarded as an actual computational implementation of representation and algorithm of language processing. Okay. But what we are missing is hardware implementation. So in order to evaluate those language processing models fully, so we have to implement those language processing systems within maybe the human brain or maybe in the machines robots. Right? So we have to implement those language models within those some hardware systems. So in doing so, maybe we should combine the traditional cognitive science of language and the neuroscience and the artificial intelligence to get the computational cognitive neuroscience research to target that the human-like language processing and language learning models by combining those three fields. All right, that's it from me. Thank you very much.
Thank you very much, Professor Oseki. Yeah, I think that language is a very interesting topic because that is a very specified skill of only human beings in that kind of high-level communication. But we can do it a symbol grounding, but language is a little bit very simple, but a little bit down from the real grounded symbol. So I want to discuss later about that.